Alright, so yeah, this will be a video real quick, um, specifically for Catherine, using Cheat Engine, but I guess this can work for about any game. Um, this is not a like intro on how to use cheat engine or reverse engineering stuff. I'm not going to teach you any hexadecimal. I'm not going to teach you pointers. I'm not going to teach you really anything. This video is just an example of me trying to go through using cheat engine and the little information that I know to start to change some values in this game called Catherine Classic. It's on Steam. Um, it there's not really any resources out there for it, and so I figured it would be useful to somebody who maybe they're doing an obscure game themselves and don't really know where to get started with Cheat Engine, or all the examples that I find they all go well and they use simple games. Maybe stuff like Plants vs Zombies is a common example. Um, but I don't see many longer videos or longer examples or things that go wrong. And so this video is just meant to kind of give maybe like a real world example or recording of somebody using it, kind of talking through their thought process, and hopefully somebody finds it useful in their own approach, maybe to their own game, or if you're looking at Catherine yourself, maybe that will give you some ideas too. So anyway, I'll just kind of jump right into it. Maybe I'll split this video up into parts, and um, maybe what we'll look at right now would be finding values, um, and eventually going from finding values to starting to find objects. And what I mean by that is, yeah, I guess first thing, maybe we want to start with player coordinates. That's usually a fair place to start. Now this is Catherine version 1.2, the second patch that's been applied. I have dual monitors, so I have the game up in the top right, and it doesn't like being recorded full screen. The game tends to crash, so I just kind of have the whole screen being recorded there. Um, the whole monitor being recorded there, and then the second monitor has the cheat engine itself. So it's a little janky, I know, but that's the way it is. Anyway, so I'm going to launch Cheat Engine. I'm going to load it up with Catherine. I have a cheat table, a CT file for 1.4, but like I said, this is 1.2, so the binary is going to be different. The executable file is going to be different, so it will not work. Um, so I'm not going to load that table, and also it won't really, give you too much if I work from something that I already have. So let's see. How do we want to approach this? We want to find player coordinates because the idea is that, the game is going to create this player object, right? It's going to take so much information and put it somewhere in memory. Um, Now, it's for usually what happens in games is where lots of information about objects is typically stored somewhat in contiguous memory. It's going to be nearby each other, right? If you think what makes up a player object, you have properties of that player, like their X, Y, Z coordinates, maybe some kind of state that they're in, um, maybe if they have like items, stuff like that, right? All these things we just call properties of them, properties of that object. And the way that it's going to kind of work is where, okay, it wouldn't make a lot of sense if player's x coordinate was stored at location 1 and the player's y coordinate is stored at location 5052, right? Because usually if you grab the x, you probably want the y as well. So typically what happens is where stuff will be near each other if it's related, right? Certainly if it's a property of a bigger thing. So that's kind of the theory that we're going to run with when we're approaching this, is that, okay, if we find the player X property, we can probably find in general the player X or the player object. And once we find the player object, we could probably look in memory and see all the related fields. So it's kind of taking a two-step approach, right? Because we could probably go through some scans and look for exact values of X, Y, and Z, but we kind of want to spice things up a little bit. So with the theory laid out, oh, again, before we hop into this, the way that you should kind of approach this stuff is kind of like a science, right? You have a theory and you test it, a theory, a hypothesis, whatever, and you test it. And if it doesn't work, you adjust your hypothesis or you scrap it entirely and start again. If you're expecting your cheat engine to kind of just work and get done in like, 10 minutes, it's kind of unrealistic, especially if you're new to it. It's going to take a lot of trial and error because that's really what science is a lot of times is just observation based and trial and error. So anyway, with that theory out of the way, let's start to do some stuff. So looking at the Catherine game, you have a board or a stage. You have blocks on it. You have sheep that move around. You can see things are laid out in a grid-like fashion. It's 3D. So looking at this specific game, maybe we can theorize, okay, these positions, they're probably whole numbers, right? They each probably refer to a point in the grid. And that it's also not terribly wide. So probably don't need to worry about, say, if you're playing a game like an RPG, like an open world RPG, you might have X and Y, Z coordinates that are floating values, right? That are like uh, X dot Y, right? Um, you might have very large numbers, right? You might be at position 1052. Um, but with this game in particular, it probably is not the case. We can probably assume that, hey, I see on the screen like there's no more than 12 blocks in a row. So the X value probably doesn't go higher than 12. Um, and they're probably whole numbers, which that's going to help us out a whole lot in terms of searching. Now, the one thing that we can't quite tell and that we won't really know is the orientation of things. That is to say, if you're looking at the screen and you have an X position, does it increase if you go to the right or does it decrease? There's no way to know, and so eventually, if you're familiar with Cheat Engine, you can see, oh yeah, there's when you start to do scans, you'll have just changed values. So that's where we'll look for things. So we have just an unknown initial value. Oh, and then we're expecting that this is going to be an integer, like we said, whole number. So it's probably just going to be 4 bytes. This is where you kind of need to know different types and how variables are stored, how many bytes they count. Maybe for your specific game, you might want to test it out. All is going to be very long. I mean, all kinds of values. So you probably don't want to do an unknown initial value all. You probably want to start with 4, maybe 8 or a float or something. But integers are going to be 4. So anyway, let's just get on with it. Do our first scan. We've got a million values here. That's quite a lot. Um, we can start to do some neat stuff though, like we were saying, okay, we can limit this. We know that the x value is probably between, we'll even say 1 and 12, because it looks like, at least in this game, that our players are roughly near the center of the board. They're not on the edges, right? So even if the orientation, even if the right side is 0 or the left side is 0, somewhere in the middle is going to be greater than 0. So we'll have our hex value start at 1, and it won't go greater than 12. So that will apply this scan to these 1,000,006 values. So we'll do that, and now we've limited it down from 1,000,006 to 2,000,000. So pretty good so far. Now we can do some other stuff here. Like I said, all I'm going to do is I'm just going to move one position in the x-axis, and I'll do the next scan. And now we've limited down from 2,000,000 to 28,000. I can see that some of these values have increased, so maybe they were at one point between 1 and 12, but after some things happened in the game, memory adjusted, and they've changed. So I probably want to go back and say value between and apply this filter again. So we'll do the next scan, and that limited us down. Now we're only at 2,000. And sometimes things you can kind of see, red means that values have changed. Things hop around all the time. Memories constantly, stuff's going in and out. And so sometimes you might want to apply the same filter multiple times. You might want to click next scan a couple times to see if you can catch it when it's really moved. Now, we've narrowed down the values a good bit. We can see that some things are changing, but we're not moving. So these values cannot be our x value. So we want to eliminate all these things that are constantly moving. So our scan type, we're looking for things that haven't changed because the game's paused. So we're going to eliminate some of those. Like I said, sometimes you just want to click next scan a couple times. Now we'll do changed value again. Do next scan. Now we're down to 242. Return to game. Changed value. And again, we're only doing changed value because we don't know if it's gone up or down. Uh, it, a different approach that we could take with this is where we could assume that left is up and right is down. We could assume those things. Um, and we could approach that. And if we were wrong, we would have to adjust the hypothesis. If we didn't get anywhere, you know. But here we're kind of leaving it open-ended. So here we're moving a little bit around. We're going to say the value is still between 1 and 12. We're down to 21 values, so that's actually pretty good. We can start to see things, you know, once you get down to where you can see everything in one screen, that's really where you don't want to, you know, you don't need to get your scan down to one value. You just need to get it down to a handful of values that you can manually look at. We know this is unchanged, blah, blah. We know a couple things too. We're looking at this. We're not even near the edges of the screen. This is where we're kind of using some logic to do some of this stuff. We know that we're not even near the edges of the screen. So our value is probably our upper limit when we did our value between. We thought, okay, yeah, the edges are going to be probably 0, 1 or something. And our most value is going to be around 12. But we're, like I said, in the middle. So we're expecting a value, you know, 5, 6, 7, something like that. So maybe we want to narrow this down a little bit more. Maybe we want to start at 4 and go all the way up to, no more than 9. That sounds reasonable for something in the middle of the screen when you only have at most 12 wide. Which this isn't even 12 wide. I'm just giving a little bit of padding. So next scan, limit that down. Now we're even down to 10. And this is very easily, we can just look at this and kind of know what's up. And this is where we could start to see, okay, we still haven't moved. So all of these things that just changed, right, they are definitely not right. So this is an unchanged value. Get rid of those. We can see that there's a 9 and there is a 5. When we move, we can see this thing is changing. So we will put this in here, and we'll just make a little note of this. We think that this is the player 2 x coordinate. Does that make sense? When we go left, when we go right, it goes down, and when we go left, it increases. When we go up, nothing changes about it. All right? That sounds reasonable to me. And then the next thing that we want to do is we want to find pretty much the pointer for this, right? We're going to find what writes this address, return to the game, move around a little bit, pause, and this is giving us the operation. Here I'm going to stop the debugger. This is giving us the instruction that is writing to this, right? This is the little bit in memory, the instructions that are doing stuff, and if you know assembly, that's great. You can kind of pick up on what's going down. If not, that's fine too. We can see that we're moving something in this register, EAX, to EDI plus 6C. EDI is 2A6022B8. Notice here that when we look at this value, 2A602 blah blah, what this probably, our theory, right, was that, okay, the player 2 x position is a property of player 2. So what this probably means is that EDI is the player 2 object start, and then 6C is what we'll call the offset of the player 2 property that leads to their x position. So what that means is that what we actually want to look for is what sets. We want to find the pointer for the player 2 object. So we want to find the pointer to just EDI, to register EDI. Or rather, I guess I should say the value that register EDI contains right now. And the pointer then that we're looking for is what points to this address, 2A blah 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 6022B8. So I will copy this, I'll close this. Not interested in this anymore. And again, the reason that we want these pointers, right, is because, well, when the game, if we make a change or something and the game crashes, or just the next time that we launch the game, we want to be able to reference the player too. So we will do a new scan. We are looking for a hex value, and we know the exact value that we're looking for is this. So hopefully this should give us something nice. And it does. Um, we know, if you're familiar with Cheat Engine, it does something really cool for you where it gives you green is our pointers. Pointers, they're offset from the process themselves, and their static pointers are great because they're always at the same location. So that means that if I reference wherever the Catherine exe program starts plus this offset, if I look at that location in memory, that value will always point to this thing that we want, which in this case is our player 2 object. So what this means is that we should add this address to the list, but we don't. It's not really the address that we want. I guess really here, what I actually want to do is I want to add the pointer. Right, so this is, I could just go Catherine.exe. This would just be whatever process you have. I'm just going to copy what this address is, plus 9645 1C, and again that is in hex. And this is, we don't want any offset because we just want this to be this. You can call this the player 2 entity, player 2 object, whatever it is. Right? We think that this is the player 2 object. And then this is, I'm just going to do a little bit of cleanup work. And then when I found when we found what wrote to this, we remember that it referenced an offset. I don't remember exactly what it was. I think it was 6C, but I'm going to load up the game and check for it. Here we can see, yes, this is great because the round ended, so we got to see that these things are probably the instructions related to reinitializing. Resetting between rounds. And certainly when you start to see stuff like move a bunch of zeros into some location in memory, that is giving you a pretty good likelihood that, oh yeah, that is some kind of initialization bit. But again, you can see that even though the base register is changing here, right, this is pointing to SI, the stack, and this is pointing to BX, that they are referencing the same offset, right, the 6C, which that's pretty good. Pretty good indication that, oh yeah, it's definitely always, that far off from the player. And again, I did some movement as well, and you can see even though that these registers are changing, where this value is stored, all of these ESI, EBX, and EDI probably are all pointing to this player 2 object. And sure enough, if I look at this, just to verify, EDI I can see here is this 2A6022B8. And here, if I look for what EBX is, I can see this is 2A6022B8. And similarly, if I look at this ESI, I can see that this is also 2A6022B8. So that's all good things. Which means that now, if I want to add this, I can add a pointer, and I can say, okay, let's start at the player 2 object, and our offset now becomes 6C. And when we do that, why is this? There we go. I guess, okay, I guess just when in Cheat Engine, sometimes you need to just give it an input for it to, like, kind of do stuff. But we can see that this is pointing to this address, which is giving you this value of 5. And here we could change the type, right? We could change it to whatever. Which, you can kind of ignore. This is just a placeholder for the player 2 object. This type isn't really right. It's a custom type, right? We don't know how many properties of player 2 there are, so that would be related to the type. And then the value's not, we don't care about this value. We just want this as a reference point for where the player 2 properties are. And you can see that, the first, the first 5 bytes of this are the same, which means that, it's just as nearby in memory. So this we'll say is the P2X pointer. And then we can clean up the specific address. Excuse me. Whew. Need to take a drink real quick. So that was an example of I'm going to stop the debugger now, of finding the player 2 object value. From the player 2 X value, we found the player 2 object pointer. And then once we found the object, then we found the actual x pointer, the coordinate pointer. We could now, if we care about the y position of our character, we could do it in a similar way. We could search for the value of y. We know that it's probably pretty low since we start at a low position on the tower. And then we climb up, so we could even we have a pretty good idea that, oh yeah, values increase as you go up, and we could do a search that way. Or we could do things a little bit snazzier, I think. Uh, Cheat Engine has a pretty cool bit where you can browse memory region. Right? So if I browse this memory region, it opens up a separate window. Top half here, this can be pretty intimidating the first time that you view it. But the top bit are all going to be related to instructions, right? You can see that there's opcodes, aka there's the assembly code. Um, and then down bottom though is actually values that are in memory. Um, which if I look back at here, you can see that, oh yeah, this address is pointing to a 6 blah blah. It's this address in memory. All these things are down here. And our idea was that, oh, the x property is going to be, you know, just some offset from this object, and that the y property is going to be some offset from this object. So if we just look at the memory viewer of the object, we should be able to find all the properties of our character. Um, Now this can be a little bit more confusing because I mean you just got a bunch of hex that you're looking at, which I mean that can drive you insane. Um, so if you're tackling it from this approach, maybe if you're doing some things, maybe you want to take screenshots frequently, right, and compare like frame by frame or state by state, and really get to tell. It's almost like a spot the difference kind of picture, right? You're just gonna start to look for things that change, and then things that change when you do something, and then assume that it's related and test it out from there. So we want to tackle this method specifically to find our player to Y position. So we will return to the game. We will move. We can see that X. We can see that there are a couple things that are updating to 5, this one and this one. And there are a couple different properties here. But the next thing that we want to find is when we go up, we're looking for something that increases. Right, so I saw that something increased to 6. I saw some 7s, and when I go up and down, I can see that one thing goes to 6, that goes to 7. And it's kind of interesting because it looks like there are a couple things here. I can probably just add these all to the list. So I will just add a bunch of things that look relevant that I just spotted, and there might have been some things that I missed that you might have seen. Um, that would just be where I would need to keep looking at. But these things kind of stood out to me when I was moving. And this one was kind of interesting because it looked like it updates after you move. So it almost looks like it keeps track of where you came from. Which, when you start to look, you'll probably see some redundant data here and there. Um, I don't know exactly why that always happens. My first instinct would be that, well, that's probably some inefficient programming on some end because ideally, you shouldn't have the same value in multiple locations, especially if it stands for the same thing. But it also could be an indicator of there's some like a more complicated process is going on somewhere that needs it, right? Like sometimes I don't know. This is where that's just me making guesswork, right? That's just a hypothesis, and I don't know enough to substantiate that. But regardless, we have a pretty good feeling that these have to do with player to Y position. Um, and there are a couple ways that we could test that. Um, but what a cool way, I think, to test is to do things where you freeze these values, right? This is the active column. When you click this X, what that means is that this value will freeze it. It shouldn't change. It will try to not change. So the idea is that, okay, if we freeze our Y position when we move in the Z plane, what should happen is that when we move down, when we move to a lower position, we should almost like fall, right? Or when we go to a higher one, we should actually like drop below the blocks. Or if we move in the X plane, if we climb on top of a block, it should actually crush us because we move into that block. Right, so I'm just going to freeze one of these and see if it's related to our position. And sure enough, when I stepped into the X plane, my I lowered, I climbed it, and then I lowered down, and died because I spawned into that one. So that seems a pretty good indicator that that is relevant. The next one would be, okay, let me freeze another one and see if that one's relevant as well. This one seems much less, it's not actually affecting my movement. So it's probably a tracker for something else. So I will reference this is 2A602344. And so there would be two ways that I could approach this, right? I could say, okay, this address, I know if I pull up a calculator, if I pull up my calculator app, Windows 10, this is the programmer calculator. You can click, the little hamburger menu, and that brings up a bunch of different things here. I would go to programmer, and I would go in hex, and I would say, okay, well, I'll take the bigger value here, 2A602344 minus where my player 2 object starts, and that's going to give you the offset, right? That makes sense. 2A6022 B8 gives me 8C, right? So then when I would add an address manually, I would go to a pointer and I would say add 8C, and this should give me my P2Y pointer. The other thing that kind of works out about this, though, too, is that when you're looking in the memory viewer, it does give you, like, the offset here. So, like, if I look, this would be, like, 2A602318 plus whatever this is, plus D4 gives you this value. So, you can reference it in kind of two ways. But so that seems kind of promising. Maybe we want to keep this as some kind of reference to something. I'm not, not entirely too sure what all these are, but maybe you would want to save them as pointers. Maybe, maybe I would save one of these as P2 Y prime pointer if I just want to keep track of it for later. But yeah, so there's my X and there's my Y. I could go through a similar process for Z, but I don't really care to right now. Um, so yeah, those were finding some concrete values. I think I'm going to stop here. I think that's a fair introduction to that. And the next thing, oh, actually, you know what? Another concrete value that might be a good thing to add would be you can see that in Catherine, the stage is falling every so often, right? Every 10 seconds or so, stage falls out. Um, and so if we wanted to control that, especially because, it kind of becomes a pain if we want to test things out and the stage falls out from underneath of us, we kind of want to find a way to stop the timer or control that in some way. And so, kind of thinking that out, I think that there are a couple different approaches that you could take. One could be that, okay, I'm going to try to find the timer that controls it, and instead of this floor falling every 10 seconds, I want to make it where the floor falls every 100 seconds, right? Or some absurd amount of time. That could be one approach. Maybe another approach is that, okay, the first floor falls, and then the second floor falls, and then the third floor falls, and so on. So maybe I want to search for what floor is falling, and I want to set it to nothing, right? If I just want to make sure that it's kind of like a janky approach, right? I'm just going to keep making the first floor fall out because that simulates it not falling. The other way I could approach it is I could find in memory the instructions for, hey, make stage fall, and instead of doing that, I could replace that with like a no op, right? I could replace that with do nothing. So I think that all three of those approaches are possible. I think that what makes the most sense for me would be tackling it where I guess in my general experience, like finding counters and timers of things becomes very difficult because it's like a moving target to where, a timer is going to increment or decrement every frame, right? And that could be very large values. So I have no idea what I'm really looking for. As opposed to having things that are in your control or that you have an idea of how they work, you can probably find it a little bit easier. So in my case, I think will work the best will be, okay, let me find what floor is falling, because I have an idea that, okay, that value should be pretty low, and I have an idea that that value should increment by 1. So I want to do a new scan. I'm not doing a hex value anymore, and I don't have an idea for what the initial. I don't know what it is, but I know that it's probably between 0 and 5. Not many floors have fallen. So I will do a first scan. It gives me 34 million, and then I will just kind of go through a series of pausing and unpausing and just seeing what happens. So now I should know that the value has not changed because no floors have fallen. Typically, um, it's easier to do unchanged later, so I let the floor fall once, and now I'm going to look for a changed value. Limit us down to 28,000. Now here I can do another value between 0 and 5, do another scan down to 6,000. Now I know that the increased value is only going to be by 1. I'll let it go again. I'll wait for the floor to fall. So floor just fell, increased value only increased by 1 from the last time. And now here you can see all these things are jumping. So 1, unchanged values get me down to 33. Again, maybe you want to click this a couple times to catch it. And then I want to only get values between 1 and 5. We're down to 22 here. That's looking pretty promising. Okay. Here, value between 1 and 5. Eliminate some more. We see that there are a couple things. We know that we're actually probably not at 1. We'll probably just eliminate a couple of those because, at least while we've been doing this, it's fallen, I think, 3 times. So maybe we'll up it to 3, and we'll see what happens. Wait for the stage to fall. Floor fell, and I saw that both of these increased. And they are nearby each other. So maybe 2777748 is nearby where a property of the stage is, or something like that. But these seem reasonable. We are going to call it stage fall. Floor to fall, maybe? Floor to fall prime. So we'll call it that. And maybe what we'll want to do is we'll want to find out what writes this address, because we want to start to find the pointer. We can see the stage fell. We saw EBX plus 0003 plus some hex value and moved this. Or add. We know that this is incrementing it. We know EAX is probably, yep, just 1. We know that in Catherine that this makes sense that this isn't a constant, because in this specific game, when players are farther apart, that more of the stage falls out. So when players are nearby each other, the default is just 1. But as a player increases, it can go up to like 5 or 10 or whatever. So that makes sense that this is a register and not a constant. We were looking at EBX here is 277388, which is we kind of had a similar idea, right? I was thinking, okay, maybe it's 48, but this looks like it's 388. So it looks like there's a lot of information that starts here. But this is plus 003C, blah, blah. So maybe next we would look for whatever this is, EBX. We want to actually find this thing and then get to the offset. That's our memory viewer. We don't care about that for now. So we're going to do a new scan. We're looking for a hex value. We're looking for this, which gives us this. This is a pointer, so this seems pretty likely. I want to add this address manually, and what will we call this? We will call this something. Catherine EXE plus this value. This offset is actually 959530. And we will just call this stage. We'll call that stage object. And then we knew that this was plus. I can probably just grab it from down in here. Yep, I want to copy this. And now we want to add this to a pointer. And yep, we want to add to that. And we want to add this. Which should give us that. Yep. And for to fall. I'll just abbreviate with F to F. And that gives us this, right? And so we actually care about both of these, I think. Um, they both seem somewhat relevant. We know this guy is 48C0 and this guy is 4B88. We can do the similar approach, right? We pull up our programmer calculator in hex, we clear it out, and now we're looking for 2777. We take the higher value and subtract it from the smaller one, and we'll get our offset. So we'll take that and we'll subtract our stage object, 2777 388 A0. Oh, did I miss something there? I think I did. 277738. Is there something I missed there? I must have mistyped something or missed something. 4B882777. Uh-huh. And this is 2773. Oh, yeah, I bloop, messed up a little bit there, right? I wonder, can you just control V in this? Oh, you can. Cool. So, probably I want to grab this. Just want to grab. Oh, didn't like that. I can just grab this. Oh, no, I didn't want to do that, actually. I want to grab the higher number first. Silly me. So, grab this, go over to here, paste this, subtract. Don't forget to close things that are open. Subtract this. Gives you 3C2E8. Copy. And so F to F pointer, add another address manually, make it a pointer, add this. I think I have to remove this, blah blah, increment this, gives me the proper point, add offset, and this we'll call F to F prime pointer. F to F prime pointer. That sounds about right. Yeah, because this guy was 3C020, and this guy becomes 3C2E8. So relatively close values. So we know those are the pointers. So we want to clean up our values. So yeah. So now we got a bunch of pointers. Clean up that, which is really cool because now when we close the game or if we do something and it crashes, we'll be able to get this stuff back. So I think I'm going to end this part and I'll record a second part for finding more interesting things.